In 1944, as American Marines advanced through the Pacific Islands, a seemingly rudimentary weapon was poised to completely revolutionize trench warfare against Japan. The M3 grease gun, a submachine gun that appeared to have been assembled in a machine shop from metal scraps, possessed a characteristic that no Japanese strategist had anticipated. Its brutal simplicity was exactly what made it impossible to neutralize. While Imperial Japanese forces developed increasingly sophisticated tactics to combat complex American weapons, they couldn't comprehend how such a primitive weapon could be so devastatingly effective in close combat. What Japanese commanders discovered in the most painful way possible was that the M3 wasn't just a weapon, it was a completely new philosophy of war. Manufactured with only 47 welded parts compared to the Thompson's 87, it could be produced by any soldier with basic mechanical knowledge directly on the battlefield. Even more disturbing, when captured by the Japanese, they discovered they couldn't replicate it efficiently, as their own military culture of obsessive precision prevented them from accepting something so crude yet functional. The true revolution wasn't in technology, it was in the American mentality of if it works, it's right, which clashed head-on with the Japanese pursuit of technical perfection. The first time Japanese soldiers encountered the M3 in combat was during the Battle of Saipan in June 1944. Lieutenant Hiroshi Yamamoto, a Guadalcanal veteran, described the initial confusion in his diary. "The Americans attacked our positions with a weapon that sounded like a broken sewing machine. We thought it was defective, but it kept working perfectly. What Yamamoto didn't know was that irregular sound, result of the low rate of 450 rounds per minute, was precisely what made the M3 so lethal in close combat. Unlike the Thompson, which fired 700 rounds per minute and quickly exhausted ammunition, the M3 allowed controlled and precise bursts. The Japanese had developed their defensive tactics based on the sound patterns of known American weapons. They knew exactly when a Thompson was reloading by its characteristic sound and took advantage of those moments to counterattack. But the M3 completely broke that pattern. Its slower rate meant American soldiers could maintain sustained fire for much longer periods, eliminating the windows of opportunity that Japanese defenders had learned to exploit. It was as if the Americans had changed the rules of the game in the middle of the match. Colonel Takeshi Nakamura, responsible for defending fortified positions on Iwo Jima, later reported, "It was impossible to predict when they would stop shooting. Our entire strategy depended on timing, and they destroyed our timing." The M3's simplicity had created a new type of psychological warfare, one where predictability, the fundamental basis of Japanese military strategy, simply ceased to exist. The real shock came when the Japanese managed to capture some intact M3 units. Major Kenji Sato, a military engineer responsible for analyzing captured armaments, was genuinely perplexed when disassembling it for the first time. "This can't be working," he wrote in a report to High Command. "It's too crude. Too simple. Where are the precision mechanisms?" Sato had spent years studying German and Japanese engineering, where each component was meticulously designed and manufactured with millimetric tolerances. The M3 seemed to violate all design principles he knew. When they tried to reproduce the weapon, the Japanese faced a devastating cultural paradox. Their craftsmen and engineers, trained to seek perfection, instinctively improved the M3's design, adding unnecessary components and refining tolerances that didn't need refining. The result were weapons that were more beautiful, theoretically more precise, but cost 3 times more to produce and were twice as prone to jamming in combat conditions. It was as if their own technical excellence had become a fatal weakness. The contrast was stark. While an American factory could produce an M3 in 2.5 hours using semi-skilled labor, the Japanese needed 12 hours and highly qualified craftsmen to create their improved version. In a war where production speed determined the outcome, the Japanese had discovered that their pursuit of perfection was condemning them to defeat. The M3 wasn't just a weapon, it was a mirror reflecting the fundamental differences between American and Japanese industrial philosophies. The psychological impact of the M3 on Japanese troops was extensively documented by Dr. Masao Watanabe, a military psychiatrist who interviewed hundreds of soldiers after the war. "They spoke of the weapon with a mixture of contempt and terror," Watanabe reported. "Contempt for its crude appearance, terror for its relentless effectiveness." Japanese soldiers, educated in a culture that associated aesthetic quality with functional superiority, simply couldn't process how something so ugly could be so effective. This cognitive dissonance created a new type of war trauma. Japanese soldiers began questioning not only their tactics, but their entire understanding of technology and industrial superiority. If Americans could create superior weapons with apparently inferior methods, what did that say about the very foundation of Japanese ideology of supremacy through perfection? It was an existential crisis disguised as a military problem. Sergeant Ichiro Tanaka, an Okinawa survivor, described the feeling. It was like discovering that an illiterate peasant could solve complex mathematical problems better than our university professors. Everything we believed about order and hierarchy began to crumble. The M3 had become an involuntary symbol of American pragmatism versus Japanese formalism, and it was winning overwhelmingly. Ballistic analysis of the M3 revealed another disturbing aspect for Japanese strategists. Its accuracy in close combat, distances under 50 meters, was superior to most equivalent Japanese weapons, despite its apparently crude construction. The secret was in the weight. At 15 pounds when loaded, the M3 was heavy enough to absorb recoil, but light enough for quick maneuvers. Its welded parts, which seemed improvised, actually created a more rigid structure than traditional machine components. Captain Nobuo Hayashi, a shooting instructor at the Imperial Military Academy, conducted comparative tests that produced humiliating results. Under ideal shooting range conditions, our weapons were superior, he admitted in a classified report. But under real combat conditions, with mud, rain, sand, and stress, the American M3 maintained accuracy while our weapons failed. It was the difference between theory and practice, between laboratory and battlefield. The Japanese discovered they had optimized their weapons for perfect conditions that rarely existed in real war. The M3, on the other hand, had been designed assuming everything would go wrong. Its crude tolerances actually allowed it to function even when dirty, wet, or damaged. It was pessimistic engineering versus optimistic engineering, and pessimism was winning the war. Each test confirmed a painful truth. Robust simplicity surpassed elegant complexity when lives were at stake. The M3's logistics created a strategic nightmare for the Japanese that few historians adequately recognize. Each captured M3 came with 30 magazines of 30 rounds, a total of 945 ACP cartridges per weapon. For the Japanese, accustomed to scarce ammunition and strict rationing, this abundance was almost incomprehensible. They discovered that Americans treated ammunition as an infinite resource, while they themselves counted every cartridge. Lieutenant Colonel Akira Matsumoto, responsible for ammunition logistics on Iwo Jima, calculated that a single American unit with M3s carried more submachine gun ammunition than an entire Japanese battalion. They fired in long bursts because they could, he wrote in despair. We saved every shot because we had to. It was the difference between a total war economy and a survival economy. Even more devastating was the discovery that the M3's 45 ACP ammunition could be used in American M1911 pistols, creating integrated logistics that the Japanese couldn't replicate. Their different weapons used incompatible calibers, complicating resupply and creating fatal bottlenecks. American simplicity had created efficiency. Japanese diversity had created chaos. It was a systems design lesson that would cost thousands of lives to learn. The moment of greatest revelation came during the post-mortem analysis of the Battle of Okinawa. General Mitsuru Ushijima, commander of Japanese forces, had developed a sophisticated defensive strategy based on fortified positions and coordinated counterattacks. His troops had been trained to exploit the known weaknesses of American weapons, the reloading moments, the firing patterns, the range limitations. But the M3 broke all these patterns. Colonel Hiromichi Yahara, Ushijima's operations chief, documented the frustration. Our soldiers reported that the Americans never stopped shooting. When we expected silence to counterattack, they kept firing. When we expected short bursts, they maintained sustained fire. It was like fighting ghosts that constantly changed the rules. The M3's variable rate, which could be controlled by trigger pressure, created unpredictable patterns that made years of Japanese tactical training useless. More disturbing was the discovery that ordinary American soldiers, with basic training, could use the M3 with devastating effectiveness in situations where veteran Japanese soldiers failed with their more sophisticated weapons. It was the democratization of lethality, a weapon so simple that anyone could master it quickly versus weapons that required years of specialized training. In a war of attrition, simplicity had become the definitive advantage. Metallurgical analysis of the M3 revealed another blow to Japanese confidence. Its welded parts, which initially seemed evidence of inferior manufacturing, actually demonstrated advanced understanding of materials engineering. The welds created points of controlled flexibility that absorbed stress in ways that rigid machined components couldn't. It was like discovering that an apparently poorly constructed building was actually more earthquake-resistant than a perfect structure. Professor Hiroshi Kimura, a metallurgist at Tokyo Imperial University, conducted analyses that revealed the M3's hidden sophistication. "The Americans understood something we missed," he wrote in a report that remained classified for decades. "They designed for controlled failure, not absolute perfection. When a part failed, the weapon kept working. When our parts failed, the entire weapon stopped." It was a radically different design philosophy. The Japanese created systems where each component needed to function perfectly for the whole to work. Americans created systems that worked even when parts failed. The M3 could lose its stock, have its barrel dented, or have internal parts damaged and still fire. It was redundancy through simplicity, an engineering lesson the Japanese only understood when it was too late. The M3's impact on Japanese close defense tactics was documented by Colonel Tadamichi Kuribayashi in his final communications from Iwo Jima. "The enemy has changed," he telegraphed to Tokyo in March 1945. "Their weapons are different. Our tactics no longer work." Kuribayashi had developed a defensive system based on interconnected bunkers and coordinated counterattacks, but the M3 made these tactics obsolete. The M3's ability to maintain sustained fire in confined spaces meant the Japanese could no longer use their tunnels and bunkers as tactical advantages. American soldiers could enter enclosed spaces and clear entire positions with controlled bursts, something impossible with higher-rate weapons that quickly exhausted ammunition. It was as if the Americans had developed a master key for all Japanese defensive locks. Sergeant Major Kuniaki Ito, a veteran of multiple campaigns, described the change. "Before, when they entered our tunnels, we had the advantage. We knew every curve, every hiding place. But with these new weapons, they could shoot continuously while advancing. There were no more moments of silence for us to move." The M3 had transformed underground warfare from a tactical chess game into systematic demolition. It was the industrialization of violence applied to the most intimate spaces of combat. The true magnitude of the transformation only became clear in Japanese intelligence reports from late 1944. Major General Tadashi Sumida, chief of enemy armament analysis, compiled data that revealed a terrifying reality. Japanese casualties in close combat had increased 340% since the M3's introduction. It wasn't just a new weapon, it was a new form of warfare that made decades of Japanese military doctrine obsolete. The numbers told a devastating story. In Saipan before the M3, the Japanese managed to inflict 1 American casualty for every 2.3 of their own in close combat. In Iwo Jima, with the M3 widely distributed, that ratio had deteriorated to 1 American casualty for every 7.8 Japanese casualties. It was a change that transformed tactical victories into strategic defeats, making any prolonged defense unsustainable. Most disturbing was the discovery that the M3 had fundamentally changed the behavior of American soldiers in combat. Prisoner reports indicated that Americans now advance more aggressively, confident in their weapons' ability to sustain fire in any situation. It was as if the M3's simplicity had given American soldiers a psychological confidence that translated into tactical superiority. The weapon not only killed bodies, it killed morale and the hope of effective resistance.